You open an app, type in an address, and a calm voice tells you exactly where to turn, down to the meter, in a language your brain barely has to work to understand. Now imagine losing that voice entirely. No satellites, no paper map, no road signs, because there are no roads, just open land, open sea, or dense forest stretching in every direction. And somehow, you still have to get home. Your ancestors did this, not occasionally, constantly, and the real answer to how they pulled it off is far stranger and more impressive than they just knew the area. Start with the obvious assumption people make, the one that's almost entirely wrong. Most people picture ancient navigation as primitive. Guesswork, luck, sticking close to familiar landmarks, and hoping for the best. The truth is closer to the opposite. Some ancient navigation systems were so precise, so mathematically sophisticated, that modern scientists are still studying them to understand exactly how they worked. Take the Polynesian wayfinders, who navigated thousands of kilometers of open Pacific Ocean, water with no land in sight for days or weeks at a time, without compasses, without instruments, without anything you'd recognize as a map. And yet they settled islands, scattered across an area larger than the continent of Asia, hitting tiny specks of land, in an ocean covering a third of the planet. That's not luck. That's a navigation system so refined it functioned like a living instrument, passed down and perfected across countless generations. How did they actually do it? Layer by layer, reading the world like a dense, constantly updating instruction manual. The stars came first. Polynesian navigators memorized what's sometimes called a star compass, the points on the horizon where specific stars rise and set throughout the year. Not just a handful of stars, dozens, sometimes over 100, each one used as a marker for a precise direction, almost like a slowly rotating signpost in the sky. Anthropologist and navigator Nainoa Thompson, who helped revive traditional Polynesian wayfinding through the voyages of the Hokulea, has described how a trained navigator could hold a course for days by tracking which star was rising over the horizon at any given moment, switching seamlessly from one to the next as the sky rotated overhead through the night. But stars only work when the sky is clear, and the ocean rarely cooperates that generously. So wayfinders built in backups, layered on top of each other, like overlapping instruments on a control panel only they could read. Ocean swells became a second compass. Long, consistent swells, generated by distant, stable wind patterns, roll across the ocean in predictable directions, even on days when the wind near the boat shifts constantly. A skilled navigator could lie down in the hull of the canoe and feel the rhythm of the swells through the vessel's movement, distinguishing the deep, steady pattern of a distant swell from the choppy, irregular surface chop caused by local wind. Some navigators were said to sense subtle differences in swell patterns, well enough to detect the presence of an island beyond the horizon, its presence reshaping the swells around it long before any land became visible. Birds offered another layer of information. Certain seabirds, like terns and boobies, returned to land every evening to roost, flying out to sea each morning to feed. Spot one of these birds far from any visible coast, and a trained eye could often estimate which direction land lay simply by watching where the bird flew at dusk. Cloud formations added yet another clue. Distinctive cloud patterns frequently form over islands as warm air rises off the land, creating a visible marker hovering above land that's still completely invisible from sea level. All of this had to be tracked simultaneously, constantly updated, cross-checked against memory, intuition, and pattern recognition, refined over a lifetime of training that often began in early childhood. There was no single tool doing the work. There was a trained mind integrating dozens of subtle environmental signals into a continuously updated sense of position and direction, something researchers studying Polynesian navigation have compared to an internal, constantly recalibrating dead reckoning system, built entirely out of memorized patterns, rather than instruments. The Pacific wasn't the only place this kind of expertise developed. Indigenous Arctic peoples, including the Inuit, navigated vast stretches of sea ice and tundra, landscapes that look, to an untrained eye, almost featureless and constantly shifting, using wind-carved snow formations called sastrugi as directional markers, since prevailing winds consistently shape snow ridges in predictable patterns across huge distances. Anthropologists studying Inuit navigation have documented hunters traveling enormous distances across landscapes with no visible landmarks at all, relying instead on memorized wind patterns, snow textures, and star positions to maintain direction with remarkable accuracy. Desert navigators developed their own specialized systems entirely. Bedouin guides crossing the Arabian desert and Aboriginal Australian peoples crossing vast stretches of outback relied heavily on what researchers call songlines or oral maps. Detailed, memorized routes encoded directly into story, song, and rhythm. Anthropologist and researcher Lynn Kelly, who has studied Indigenous memory techniques extensively, has described how songlines function as elaborate memory systems, embedding navigational details like water sources, landmarks, and turning points directly into the structure and sequence of a song, making the route nearly impossible to forget, because the information was woven into something the brain naturally retains: rhythm, melody, and narrative. Walking the song line and singing it were, in a real sense, the same act. Here's what ties all of these systems together, despite arising independently in completely different parts of the world. They all depended on an extraordinary trained relationship with environmental detail. Not casual observation, but deep, practiced, almost obsessive attention to subtle patterns most people today would walk straight past without noticing. The angle of a star, the rhythm of a swell, the direction a bird flies at dusk, the texture of wind-blown snow. This raises an uncomfortable question about modern life. That trained attentiveness didn't disappear because the human brain changed. It disappeared because it stopped being necessary. Researchers studying cognitive offloading, the tendency to outsource mental effort to external tools, have found that reliance on GPS navigation appears to measurably reduce activity in brain regions associated with spatial memory and mapping, including the hippocampus, an area long studied for its central role in building internal mental maps of the world. The ancient skill of wayfinding wasn't lost, because humans became incapable of it. It was simply handed off to a tool that does it faster, and the part of the brain that used to do the work quietly, gradually, stopped being exercised. There's something worth sitting with in that. Your ancestors carried, inside their own heads, navigation systems so sophisticated they could cross oceans without a single instrument, tracking stars, swells, birds, and wind, with a precision modern researchers are still working to fully understand. That capacity hasn't vanished from human biology. It's simply gone quiet, waiting for a reason to switch back on, buried under a few generations of turn-by-turn directions, and a calm voice that always tells you exactly where to go next. Next time the signal drops, the battery dies, or the map app simply stalls out somewhere unfamiliar, you might notice an old, almost forgotten instinct quietly switching back on, checking the position of the sun, the direction of the wind, some small detail in the landscape your conscious mind never thought to name. It won't get you across an ocean, but it's the same ancient circuitry your ancestors once trusted with their lives, still sitting there, fully wired, just waiting for the world to ask something of it again. It helps to understand just how long this training actually took to build, because it puts the skill in proper perspective. A Polynesian navigator wasn't handed a manual and sent out to sea. Becoming what's traditionally called a master navigator, or palu in some island cultures, could take decades of apprenticeship, often beginning in early childhood and continuing well into adulthood, under the direct mentorship of an experienced wayfinder. Students memorized star paths through repetition, practiced reading swells by lying in canoes for hours at a time, and absorbed an enormous, structured body of knowledge passed down almost entirely through oral instruction. Since many of these cultures had no written navigational charts at all, the knowledge lived in people, not in paper, which meant losing a single master navigator without a trained successor could mean losing centuries of accumulated expertise in a single generation. This oral transmission explains why so much of this knowledge nearly vanished during the era of European colonization and contact. As Western navigation tools spread, traditional wayfinding practice declined sharply across much of Polynesia, and by the mid-20th century, many considered the deep tradition of long-distance, instrument-free voyaging essentially extinct. It took a deliberate, sustained revival effort, including the construction and voyages of the hokulea, a traditional double-hulled canoe built in the 1970s. Specifically to test whether ancient wayfinding techniques could still successfully guide a vessel across open ocean, to prove the knowledge could be reconstructed and passed forward again. Navigator Mau Piailug, one of the last fully trained traditional navigators from the Micronesian island of Satawal, played a central role in that revival, teaching wayfinding techniques to a new generation specifically so the knowledge wouldn't disappear entirely from human memory. The Arctic and desert traditions face their own versions of this fragility. Inuit elders have described how reading sastrugi, the wind-carved snow ridges used for direction, requires not just memorizing a single pattern, but understanding how local wind behavior shifts across seasons and specific stretches of terrain. Knowledge built through years of travel alongside experienced hunters, rather than learned from any single lesson. Aboriginal Australian songlines carried similar depth, often stretching across enormous distances and multiple language groups, with custodianship of specific song sections passed down through particular families or clans, each responsible for preserving their portion of an oral map that, pieced together, could span an entire continent. What's striking, looking across all of these traditions together, is how much cognitive effort modern life has quietly removed from daily existence. Researchers studying spatial memory have found that experienced taxi drivers in London, who must memorize an enormous, complex web of streets to pass a notoriously difficult licensing exam, show measurable structural differences in their hippocampus compared to non-drivers, with the region associated with spatial memory appearing physically larger in those who've spent years building and using detailed mental maps. It's a small, modern echo of exactly the same principle ancient navigators relied on for survival. That the brain, given a genuine reason to build and maintain a mental map, will rise to meet that demand, growing and strengthening the very structures responsible for the task. That's the real story hiding underneath the question of how ancient humans navigated without maps. They weren't missing a tool modern humans simply happened to invent later. They were running a different kind of map entirely. One stored in memory, refined through training, and built directly into the structure of the brain itself. Layer by layer, generation by generation, until reading the sky and the sea became almost as automatic as reading a written sentence is to you now. Next time the signal drops, the battery dies, or the map app simply stalls out somewhere unfamiliar, you might notice an old, almost forgotten instinct quietly switching back on, checking the position of the sun, the direction of the wind, some small detail in the landscape your conscious mind never thought to name. It won't get you across an ocean, but it's the same ancient circuitry your ancestors once trusted with their lives, still sitting there, fully wired, just waiting for the world to ask something of it again.